For preparing the liquid ethane, it's good to wear at least some protection for your face or for your eyes, because when preparing the ethane might splash up and could hit your eyes. So it's always good that when you prepare liquid ethane, you use the proper safety measures. Now, to prepare the liquid ethane, we start again with the assembly of the tray, which starts with the base tray. Then we have again the holder that holds the grid box, the storage for the grids. Then we place the ethane cup from brass in the center, the spider which cools the center of the cup, because the cup is insulated by this outside. So we put liquid nitrogen on the outside ring, which will not cool down the central part. If we would put the brass cup directly into the liquid nitrogen, what would happen is we would still create liquid ethane here. However, liquid ethane turns solid at minus 180 degrees. And since liquid nitrogen is colder than minus 180 degrees, at some point the liquid ethane will solidify and then we cannot plunge freeze. So the way that we can make the liquid ethane without it being solid, we put a cup in the center which is insulated, and then via these spider legs we cool from the outside the inside of the cup. And once the liquid ethane is formed, we can then remove the spider, and then we will have some liquid ethane that we can work with for about 30 minutes. So this spider will go on top, and finally we have the anti-contaminator ring which floats. Be aware that it has these notches at the top. So this is the upside and this is the bottom. The bottom is flat, and these notches are a bit higher so that we create some distance between the Vitrobot and assembly. Otherwise it might freeze to the bottom. So this is how we start, and then we start by taking liquid nitrogen and filling the outside of the tray. So we can also fill here on the outermost side, especially when you have ethane being formed in the center. You don't want to pour any more liquid nitrogen in the center, because you run the risk of pouring liquid nitrogen straight into the liquid ethane, which then again has a splashing hazard but also solidifies. Now, what you have to look for now is the heavy bubbling, and especially listen to the sound. I always pour some nitrogen in the center cup, and now look at the heavy bubbling. We're still in the phase where we have the Leidenfrost effect, and that means that there is an insulating layer of gas that is between the liquid nitrogen and the surface. And we have to wait until that gas layer is disappearing, and that happens when the surface has the same temperature as the surrounding liquid nitrogen. And you can clearly see that by a sudden heavy boiling, but you can also hear it coming. So we now have a microphone very close to the center, so you can hear it. And this is true for any part that you want to cool down with liquid nitrogen. You always have to wait until you see this heavy boiling and you hear this hissing sound, which is the Leidenfrost effect, when all the vapor that protects the surface between the liquid nitrogen and the surface instantly disappears all at once. So we still see that the liquid nitrogen is boiling, and that means that the central brass cup still isn't at the temperature of liquid nitrogen, which is minus 196 degrees Celsius. And I will keep pouring a little bit of liquid nitrogen in the center to speed this process up. But you have to be aware that at the end, when you're getting very close to this Leidenfrost effect, you don't want to fill up the entire cup, because then you're left with a lot of liquid nitrogen in the center, in which you cannot make liquid ethane. So if you would blow ethane gas into that liquid nitrogen, it would solidify. So now you hear the effect coming. Okay, that was it. So you saw that was a sudden heavy boiling and a hissing sound. And if you now look at the center, there's still a small layer of liquid nitrogen there, but it doesn't bubble anymore. So that means that the central cup in which we put the ethane vapor has the same temperature as its surroundings, so is at liquid nitrogen temperature. We can now start making our liquid ethane. And we do this by taking the nozzle coming from the bottle. So remember that we have the bottle, the main valve opened, we have the reduction valve set to a certain exit pressure, and we're now going to open the flow regulator. And we do so by putting the tip of this nozzle inside completely, down at the edge, and then we slowly open. And also here you have to use your ears until you hear this sound. This sound is indicative of a liquid that is being slowly blown, or a gas that is being slowly blown into a small layer of liquid. So that means at the bottom we have some liquid ethane that is formed. So, and we keep the tip of the nozzle pressed to the edge of the cup. And since the ethane is a very dense vapor, in the beginning you only have your ears. So now that this vapor disappears, you can actually start to see that there is some ethane. And I actually go a little bit up and down with the nozzle, especially in the beginning when there is a small layer of liquid nitrogen still present. You run the risk that the first ethane that comes out solidifies and blocks your tip. So you have to go a little bit up and down to make sure that this solid ethane is not formed and not blocking the tip. And once you have a layer of liquid ethane, you can slowly lift the tip, and you can actually hear when you're reaching the surface, which is there. When you're out, you hear the hissing sound of gas, and when you're in, you hear this liquid. And you can now slowly increase the flow to fill up the ethane a bit more quicker once you have a layer of ethane being formed. And by lifting the nozzle slowly up together with the rising liquid ethane level, you get a feeling how full the cup already is. And we have to fill this cup all the way up to the bottom part of the spider. So don't fill it all the way to the top of the spider, because then you run the risk that the spider gets frozen solid to the ethane cup. And you can start seeing bubbles at the edge to also give you an indication where the top level of the ethane is. And I'm using these bubbles, so I'm keeping the nozzle slightly under the surface of the liquid ethane. And the moment these bubbles are hitting the cooling spider, that's when there is enough liquid ethane present in the center. And when you reach the surface, it's good practice to reduce the flow again. You have to be aware that when you close the flow of ethane and this tip is still in your liquid ethane all the way down, the ethane will be sucked into your pipette via capillary force, which is something you don't want. So when you're close to the end, which is now, bring the flow back. You can use your ears again, and then with a little bit of flow take the nozzle out and then close the valve. So now you can see that the bubbles are almost touching the spider. So now we're almost full. I again reduce the flow, and I'm now going to take the nozzle out with a little bit of flow still coming out to prevent the ethane from coming back into my pipette with capillary force, and then I'll close it completely. So that's it. So now we have a filled cup, and we have to wait until this is cooled down enough. So we can add a little bit of liquid nitrogen, but now add the liquid nitrogen only to the outside. Don't pour it inside. Also be aware that when you pour, you can also pour nitrogen vapor, which is cold as well. So if you want to make sure that this central part is clean, you can actually pour, like you can see here, you can pour nitrogen vapor on the inside, and you can pour liquid nitrogen to raise the level on the outside. So be aware that this ring now creates a nitrogen atmosphere around the center of the cup. So this is also a protective atmosphere that makes sure there is not a lot of contamination coming to the center. And you can see here that the level of ethane is at the lower side, so there, of the spider. So it's not to the top, but it's to the bottom. And what you have to look for now is the creation of solid ethane. Ethane turns liquid at -80. So the temperature, the boiling temperature basically of ethane is -80 degrees. So that's where ethane turns from a gas into a liquid. If we would plunge freeze in freshly made liquid ethane, the temperature would be -80. Now the devitrification temperature of water is about -150 degrees C. That means that the ethane, when it's just made, is too warm for water to be vitrified. So if we would plunge freeze with freshly made liquid ethane, we will get crystalline ice. And that's what we like to avoid. We want to have vitreous ice. So therefore the temperature has to be colder than -150 degrees Celsius. We can see that by waiting for the ethane to solidify. So as long as these spider legs are cooling the center, the temperature, the conduction temperature, is still that of liquid nitrogen, -196 degrees. The temperature at which ethane solidifies is -180, which is cold enough to freeze. So what you have to look for is now you can already start to see a small white edge, and that is the liquid ethane turning solid. Also at the bottom you can now start to see that it turns white. So ethane is now at the melting temperature, and that is at -180. Now we can use now a pair of pliers to pull this spider off because it's frozen solid to the top. There's also a trick. We can take a second brass cup, place it on the top and heat a little bit that spider, and then we can very easily take it off. So there we have it. We now have an insulated cup with liquid ethane inside, and you see that the edge is solidified. So this is liquid ethane at its melting temperature at -180 degrees Celsius. This we can now use to start preparing our specimens.